Welcome to Solar Age, the podcast that shines a light on the path to a brighter, more sustainable future. Join us as we explore the transformative power of technology in creating a solar punk world.
Hey everyone, and welcome back. You know, we got a ton of messages after that last deep dive on the solar age.
Mm-hmm.
A lot of you had questions about volcanoes
Yeah,
and climate change,
for sure.
especially about whether volcanoes are actually the main thing causing temperatures to rise.
Right.
So today we're going to tackle that very question.
Okay.
We're diving into this article from Salon.
All right.
It's called Volcanoes Don't Cause Climate Change, but It Could Be the Other Way Around.
Interesting.
And it is a real eye-opener, let me tell you.
Okay, I'm ready.
Get this. There's a chance that climate change could actually lead to more volcanic eruptions.
Oh, wow.
So let's get started and unpack this whole thing.
Absolutely. And I think a great place to start would be with some recent news out of Iceland.
Okay.
Scientists there are keeping a close eye on the Astja volcano.
Uh-huh.
There's been a significant magma buildup.
Now, Askrija, that's a pretty big deal, right?
Yeah.
For our listeners who might not know,
Right.
we're talking Mount St. Helens level here.
Yeah, that's a good comparison.
And it's in Iceland, which is, well, kind of a volcanic hotspot.
Exactly. Iceland sits right on top of one of the Earth's most active volcanic zones.
Uh-huh.
And it's also a place where glaciers are melting really rapidly because of climate change.
Oh, wow.
So it's like a perfect natural laboratory for studying how these two powerful forces might interact.
So you're saying there's like a direct connection between the melting glaciers and what's happening with the volcanoes.
Yeah, that's what scientists are looking into.
Okay.
The Icelandic government is actually funding a study to investigate this link.
Wow.
And the science is really fascinating.
Okay.
You see, these massive glaciers have been pressing down on the Earth's crust for thousands of years.
Uh-huh.
As they melt, that pressure decreases,
Okay.
and it could actually allow more magma to rise up from below.
So like, if you take the weight off the lid of a pressure cooker,
Exactly.
things start to bubble over.
It's a great analogy. And
Yeah.
this isn't just some isolated thing happening in Iceland.
Right.
Michelle Parks, she's a volcanologist working on the project.
Okay.
And she put it this way. She said, "At the end of the day, what we're aiming for with this project is a much bigger picture. It's the future of volcanic eruptions.
Okay.
How large can they be, and what's in store for us in the future, not only in Iceland,
Right.
but for the rest of Europe and potentially farther afield."
So the implications of this research could be much broader than just Iceland.
Exactly.
It's about understanding how climate change could be influencing volcanic activity on a global scale.
That's right.
But before we get too far ahead of ourselves,
Yeah.
let's address the elephant in the room here.
Okay.
This misconception that volcanoes are the main driver of climate change.
Right.
You know, we hear this a lot, especially from people who are skeptical about, the role of human activity.
Yeah. It's a common argument, and it's important to set the record straight.
Yeah.
Volcanoes do release carbon dioxide, but it's a tiny fraction compared to what we humans pump into the atmosphere
Right.
through things like burning fossil fuels and cement production.
Exactly. To put it in perspective, human activities release around 37 billion metric tons of CO2 each year.
Wow.
Volcanoes.
Yeah.
They contribute about 100 times less than that.
That's a huge difference.
So while volcanoes can have like a temporary impact on the climate,
Sure.
their overall contribution to global warming is minuscule compared to the impact of our own actions.
You got it.
So the science is clear. We can't blame volcanoes for the climate crisis that we're facing.
Yep.
We are the main drivers of climate change.
That's right.
But what about the other side of the coin?
Okay.
This idea that climate change itself could actually trigger more volcanic activity.
Right.
That's where things get really interesting, wouldn't you say?
Absolutely. Scientists have been looking back at historical patterns,
Okay.
and there's evidence to suggest that this might actually be the case.
Yeah.
During the last ice age, which ended around 10,000 to 15,000 years ago,
Right.
volcanic eruptions were 30 to 50 times more frequent than they are today. And one leading theory is that as the massive ice sheets retreated, it reduced the pressure on the Earth's crust,
Okay.
leading to a surge in volcanic activity.
So if that pattern holds true and glaciers continue to melt at an accelerated rate because of climate change,
Yeah.
are we potentially looking at a future with more frequent and more intense volcanic eruptions?
That's the million-dollar question.
Yeah.
And it's one that researchers are actively investigating.
It's like we're entering uncharted territory.
It really is.
So I want to hear from you.
Okay.
What are your thoughts on this so far? What jumps out at you as particularly interesting or significant?
Whoa.
And perhaps more importantly, what implications does this potential increase in volcanic activity have on our understanding of climate change? Stay tuned, because we're about to dig even deeper into this explosive topic.
Yeah, it's a complex topic, but it raises some really important questions.
Right.
You know, thinking about the potential for increased volcanic activity.
Right.
It adds another layer of complexity to this whole climate change puzzle.
Right.
And it's not just about, you know, those immediate visible impacts.
Oh, right, like the ash clouds,
Right.
lava flows,
Yeah.
and the immediate dangers.
Exactly.
It's easy to just focus on the dramatic visuals,
Yeah,
but there's so much more to think about.
for sure.
What about the long-term effects of volcanic eruptions on the climate?
That's a great point.
Yeah.
Volcanic eruptions release various gases and particles into the atmosphere.
Okay.
And these can actually have both warming and cooling effects on the climate.
Okay, wait, so how can volcanoes both warm and cool the planet?
It does seem counterintuitive.
Yeah.
Well, some volcanic emissions, like carbon dioxide,
Uh-huh.
are greenhouse gases.
We've talked about those.
Yeah, we have.
They trap heat and contribute to overall warming.
Right. But eruptions also release other things like sulfur dioxide,
Okay.
which forms sulfate aerosols in the atmosphere.
Now, when you say aerosols,
Mhm.
what exactly are we talking about?
Think of them as like tiny particles suspended in the air.
Okay.
And what's interesting about sulfate aerosols is that they can actually reflect sunlight back into space,
Uh-huh.
which has a cooling effect on the planet.
Ah, so it's like a delicate balancing act
Right.
between these two opposing forces. The
Exactly.
warming from greenhouse gases and then the cooling from these aerosols.
That's a great way to put it.
Yeah.
The net effect of a volcanic eruption on climate really depends on a lot of different factors.
Oh, okay.
Things like the size and intensity of the eruption, the specific mix of gases and particles that are released, and even the location of the volcano can all influence the overall impact.
So it's not as simple as saying that all volcanoes have the same effect on climate.
No, not at all.
There's a lot more nuance to it.
Absolutely. And to make things even more complicated, the effects can change over time.
Oh, wow.
So the initial cooling effect of sulfate aerosols usually lasts for a few years, while the warming effect of carbon dioxide can persist for much longer.
So it sounds like trying to predict the long-term climate impact of all this increased volcanic activity
Yeah,
is a pretty complex challenge.
it is a challenge.
Yeah.
Scientists are using advanced computer models to try and simulate these interactions,
Uh-huh.
but there are still a lot of uncertainties.
But I think one thing we can say with certainty
Yeah,
is that human activities are the dominant force behind climate change right now.
oh, absolutely.
That's undeniable.
We can't lose sight of that fact, but
Yeah.
understanding the potential role of volcanoes in a changing climate
Yeah.
is still crucial for making good decisions about how we adapt and how we mitigate further damage.
I completely agree.
Yeah,
It's about being prepared for all possible scenarios.
right.
And that includes the potential for this increased volcanic activity down the road.
And this brings us back to Iceland, which is like a living, breathing example of all these complex interactions we've been talking about.
Right. And if history is any guide, we could be heading toward a period of, significantly increased volcanic activity
Right.
as those glaciers continue to melt.
Yeah, that's a key takeaway from our discussion today. While we can't predict the future with absolute certainty,
Right.
this historical precedent gives us every reason to pay very close attention to what's happening in volcanically active regions like Iceland.
Okay, so let's kind of shift gears a little bit
Okay.
and talk about the potential consequences of, more frequent and more intense volcanic eruptions.
Right.
Let's start local.
Okay.
What kind of risks are we talking about here?
Well, on a local scale, the immediate dangers are pretty obvious.
Right.
Ash clouds from eruptions can disrupt air travel.
Uh-huh.
Lava flows can destroy infrastructure,
Yeah.
force people from their homes.
Right.
And volcanic gases can pose serious health hazards.
Those are some pretty immediate and significant risks.
They are.
But what about the bigger picture?
Okay.
What about those potential global consequences?
That's where things get even more complex and far-reaching.
Okay.
We've already talked about how eruptions can affect global temperatures.
Right.
So a surge in activity could lead to more climate variability and potentially even more extreme weather events that we're already experiencing.
So we could be looking at a sort of feedback loop here.
Right.
Climate change leads to more volcanic activity.
Yeah.
which in turn further exacerbates climate change.
It's a vicious cycle.
Yeah, almost like a vicious cycle.
Precisely. And it really underscores the urgency of addressing climate change now.
Right.
The longer we wait, the greater the risk of triggering these types of feedback loops that could have cascading and unpredictable consequences.
This is some seriously thought-provoking stuff.
It is.
It really highlights the interconnectedness of our planet
Yeah.
and the far-reaching consequences of our actions.
Yeah, it really does.
Yeah.
It's a reminder that we live on a dynamic and constantly changing planet. And we need to approach these challenges with a sense of humility, curiosity, and a deep commitment to finding solutions.
I couldn't agree more. Yeah, it really is mind-blowing when you think about it.
It is.
You know, we often hear about climate change in the context of like rising sea levels,
Right.
extreme weather, and those sorts of things.
Yeah.
But this possibility of increased volcanic activity adds a whole new dimension to the challenge, doesn't it?
It certainly does.
It highlights how interconnected all of the Earth's systems truly are,
Yeah.
and underscores the fact that, you know, our actions can have these ripple effects that we might not even fully grasp yet.
It's true.
So where do we go from here?
Well-
What can we actually do with this knowledge?
First and foremost, we need to keep supporting scientific research in this area.
Okay.
The more we learn about the connections between climate change and volcanic activity,
Right.
the better prepared we'll be to anticipate and hopefully mitigate the risks.
Knowledge is power, right? The more we understand, the better equipped we'll be to face these challenges.
For sure, but beyond research,
Yeah.
we absolutely have to keep working on reducing those greenhouse gas emissions,
Right.
slowing down the pace of climate change overall. That's the single most effective way to reduce the chances of triggering these potentially catastrophic feedback loops.
So even though volcanoes aren't the primary cause of climate change, there's still a significant factor in this intricate web of interconnected systems.
Yeah.
Understanding how they fit into the bigger picture could be, you know, really crucial
Absolutely.
for safeguarding our planet's future.
I couldn't agree more. It's a potent reminder
Yeah.
that we live on a planet that's dynamic, constantly evolving, and full of surprises.
Right.
We need to approach these challenges with humility, curiosity, and a steadfast commitment to finding solutions.
Beautifully put. And on that note,
Yeah.
I think it's time to wrap up our deep dive into volcanoes and climate change.
Okay.
It's been a truly fascinating and thought-provoking exploration, and I hope you, our listeners, found it as insightful as we did.
It's been a pleasure delving into this topic with you.
Likewise.
And remember, everyone, the conversation doesn't end here.
Right.
Keep those questions coming, stay informed, and let's all do our part to protect this incredible planet we call home.
Until next time, keep exploring, keep learning, and keep diving deep.
Thanks for tuning in to Solar Age. We're grateful to have you with us on this journey toward a brighter, sustainable future. If you enjoyed today's episode, please like and subscribe. It really helps us spread this positive message. We would also love to hear from you. Leave a comment sharing your thoughts on today's topic, or let us know what you would like us to explore next. And don't forget to check out the description for links to relevant materials.